This doesn't work for all numbers, but for the exponential expressions n to the power of 1, 3 cubed, and 4 squared, when you multiply the base of those numbers by their exponent and then multiply that solution by the original exponent, you get the same answer as the original exponential expression. This can be expressed as x to the power of n is equal to xn squared. However, I've found that this is only true for any number to the power of 1, because that process would give you the same answer as any number to a power of 1, because any number to a power of 1 is itself. It's also true for 3 cubed, because 3 cubed is 27, 3 times 3 times 3, or basically another way to visualize it is you would get 3 times 3 is 9, and then 9 times 3 is 27. Yet this is also true for 4 squared, because you could do 8, you do 4 times 2, and that gives you 8, and then you do 8 times 2, and that gives you 16. Now, that formula that I was saying, x to the power of n equaling xn squared, is only true for these exponential expressions, and I'm wondering if I'm missing something and there are more expressions out there. Or are these numbers special and more than just my perception? Are these numbers something part of something bigger, like somebody that understands math? Help. This video helps demonstrate exactly what I'm talking about by showing a graph towards the end.
Find out for what values of x and this equation holds true. First, let's write out our equation. We have x to the power of n equals x times n, all multiplied by n. Now, let's simplify the right side of the equation. The parentheses aren't necessary, so we can rewrite it as xn times n. Let's simplify further. Multiplying n by n gives us n squared. So our equation becomes x to the n equals x times n squared. Now, to solve this equation, we need to consider the case where x is not equal to 0. If x is not 0, we can divide both sides by x. This equation shows the relationship between x and n. For the original equation to be true, x and n must satisfy this relationship x raised to the power of n minus 1 equals n squared. Let's visualize this relationship on a graph. We'll plot x caret, n1, and n squared for different values of n. The blue curve represents x caret, n1, and the red curve represents n squared. Where these curves intersect, that's where our equation is true. For example, when n is 2, both x caret, n1, and n squared equal 4. This means when n is 2 and x is 4, our original equation is true. In conclusion, the equation x to the power of n equals xn. N is true for any pair of x, and n that satisfies the relationship x caret, n1 equals n squared, with x not equal to 0. The specific values will depend on this relationship.